the ramps, board, and rep smart display, and then stops. If we still have our power supply nearby, we'll take the wire that we set up like this for our accessories, fans, and everything else. Put a little electrical tape over the end of them, separating them. So we will be using some power going on here, and we don't want these to short to each other. Okay, so you got those isolated. The RAMPS board is here. You'll find some heat sinks. These will go on top of your stepper motor drivers. Should be 5. Peel the tape off the back, and I don't have enough fingernails for this, so and we're placing the heat sink over the processor because that's the part that gets hot. Should end up something like that. This is our power connector. It connects in like this, slides into there. See from the other side. We are going to connect our power supply ends to this. Now the way this goes, you can probably see it on the RAMPS board itself. I'll try to show you. Negative, positive, negative, positive. You could just see that inside. So you want to put that in the same way. So we'll go like this, where we have negative, positive, negative, positive. Your connection should look like this in the proper orientation. And that just plugs in. For your end stops, my kit came with the MakerBot style end stop. This MakerBot style end stop, it does have a LED that lights up to indicate whether the circuit is open or closed. We're not going to use that. Like, even though this it's a 4-pin connector with 3 wires down to a 3-pin. We can actually take this down to 2 pins, and I'm just assuming that your kit is the same. You could have a different type of end stop. With this end stop, you'll have green to the left on the switch side, red on the far side, and black in the middle. The red wire only powers, it gives power to that LED. Now, some people have had problems shorting out and basically burning up their RAMPS board by using that third wire. So what we'll do, we'll take out the DuPont connection. And when I say some people, I include myself. We're only going to use the 2 wires. This is all we need. We don't need the LED, and we don't want to risk burning out this board. You could tape this off or something, but it's not something I plan on ever using. Fortunately, the RAMPS board, while the print is small, it is labeled. You see that end stops, and it goes in order: X min, X max, Y min, Y max, Z min, Z max. We're only going to use X min, Y min, and Z min. You can use the max end stops, but my kit came with 3 and I'm using 3. I'll use software to, I'll let the software determine the maximum travel distance. The end stop goes green wire to the edge of the board, or green wire goes to the edge of the board here, or where the signal line, the S is for signal. So that end stop is wired up for the X-axis. That'll go for into the Y min. This is my extruder cable.
This 4-pin connection. Look on your RAMPS board. You should see E0 and E1. We're going to plug the 4-pin into E0.
This is my Y motor. It also has the blue wire going away. And if it doesn't work for you, take it out and flip it over so that's the other way. I mean, with these pin connectors, only 2 ways it can go in. And then our Z motor, because of the type of printer we use and this setup, the Z motor is actually going to go a different way. Now, for the Prusa type printers, it takes 2 Z motors, and this board is set up to accept 2. You see 2 rows where it says Z right there. You want to plug into the top set of terminals. Difference being the blue will go to the back on this. Hopefully you also sprung for a display controller. You have 2 ribbon cables that connect the display. This connection. Okay, that's our display adapter. These are notched.
Both the connection end is slotted as well as the input side. So there's only one way that these pins can be inserted.
Keeping these in line. They go in the exact same way. In order to make this initially run, your RAMPS comes with the USB cable, and we'll have to add firmware to it. In the port here, you can plug that in. And you will need to download Arduino if you don't already have it, and you need to download a firmware such as Marlin. Before we go too far, let's back up. Hot end wires. There is no polarity on these, so it does not matter. You'll see D10, D9, D8. D10 is where you would make the connection. You want to connect the extruder to these points. The fan wires for like PLA cooling or active cooling or firmware control cooling, they go into D9. D8 is for your heat bed. For heat sensing, this is the thermistor from our hot end. You can see there we have T0, T1, T2. The T's are for thermistors. T0 is the thermistor that we want. There's no polarity on the thermistor. It doesn't matter which way you plug it in. T1 thermistor will be for the heat bed. If we had a second extruder, we would plug that into T2. Now for the time being, I'm going to disconnect the thermistor. I'm going to put the extruder cable back on, because we're going to do some firmware, and then we'll also test the movement of the printer. See if we can get this thing to come to life.
In order for you to have done this part, you need to go to arduino.cc and download the IDE. Not all IDEs offered by Arduino are the same. The current version I'm using is 1.63. Now, what you need to do is go down to Tools, go down to Board, and make sure that Arduino Mega or Mega 2560 is selected. Then check your ports, make sure that the COM port is the same and has your Mega selected. You can see that in the lower right hand corner of the Arduino software. To verify that, make sure those are the same. Then you want to go down to Programmer and make sure that Arduino as ISP is selected. With these things, you should be able to make this work. Now, normally when it starts up, it comes out to the main file. You need to go find the tab that has configuration.h. If you scroll down to around line 345 in the firmware version of Marlin that we have loaded, you'll see X max, X min, Y max, Y min, Z max, Z min, and these are the print dimensions as far as the travel distance on each axis. Now, the default values there should work out of the box to get you started. There'll be more fine tuning. Click verify, which is the check mark, and that will compile the sketch and make sure that there's no errors. Okay, no errors are present. And now we can click the arrow, which is upload, and it'll actually recompile the sketch again and upload the sketch to the Arduino. While this is uploading, you will see a blinking LED on the Arduino board. It'll blink very rapidly, almost to the point of being solid. You may see an error. In my case, the UG8 library. I have several of these libraries installed in different locations, so it gives me a warning that, I just get this kind of warning. You will need this, and if you don't have this installed, you will be prompted to install it. And that is easy to find. Just Google the UG8 library, and that is required if you're using the RepRap Discount Smart Display. Okay, so now it's uploaded, it's complete, and we should be able to check out the functions of the printer at this point.
If you have everything up and running, go ahead and throw in a Z-min end stop. And with that, I can hear the printer. So that gives me power. I'm plugged in. Okay, we've temporarily installed an end stop, X-axis end stop, temporary, Y-axis end stop, temporary, and I couldn't get this one to go on on the linear rod because it just slid around too much. So I ended up clamping a bar, taping it to the bar, and using the Z platform as the actuating object. So with that, we can go prepare. And auto home. Yes. So that homed just, it's almost like printing perfect. We'll just move one and we'll move X. And I'm going to move this until the printer is at the edge of the print bed. Or until it hits its support. So it topped out at 292 because that's what the firmware says. Now we'll move the y-axis. I'm going to have to make an adjustment on those motors. Okay, that went to 250. So we know we can go further than that. Take a measurement from the extruder to the bulldog clip, and we probably can go another 55 centimeters. Or 55 millimeters. I wish we could go 55 centimeters. So 55 additional on the y-axis. Now let's see the distance on the z-axis. Already at 200. Alright, in the firmware, we're going to increase that to 295. We'll increase to 275, and we'll keep the Z exactly the same. I'm going to save this as a new firmware. We'll save as printer 2. And we'll upload. That's what you need to do to get your printer dialed in. Just use your LCD controller, get some in-stops in temporarily, auto home it, and then move the axis, and you'll see on the readout what the position is. You move it until you start getting resistance, or you start hearing it miss steps because the axis can't go any further. And then the values that you have there, then you update your firmware with those in the configuration.h file. So with that, we will see you next time. I'm going to start working on cleaning up my printer here, make sure everything works right and looks right.